Hi, so I'm going to approximate pi through the area of a polygon inscribed in a circle and the radius is 1. So if we start with a circle with the radius 1, we can make it into a square, obviously, just by extending the radiuses and attaching these lines, and we'll get this figure here. And this middle angle is 360 divided by 4, which is 90 degrees, and this is because there's obviously four triangles inside of this figure. And if we focus on one of these smaller triangles inside, it's actually a 45, 45, 90 triangle because it's an isosceles. And we know that a 45, 45, 90 triangle is x, x, and x root 2. And in this case, it's going to be 1 over root 2, and 1 over root 2 because that is the radius. So the area of this entire figure is 4 times the area of the triangle because there's obviously 4 triangles in it. And in the area of a triangle is 1/2 base times height. So it's 4 times 1/2 times 2 times 1 over root 2 times 1 over root 2. And it's 2 times 1 over root 2 because that's our base. And we only got one of these sides. And we need to have, this is 1 over root 2 and that's 1 over root 2. So it's obviously 2 times that. So what we end up getting is 4 times 1 over root 2 times 1 over root 2 because these 2's cancel. And that ends up equaling 2, but that's not really important to us right now. What we get actually is the area of a four-sided figure is 4 cos 45 sine 45 because cos is the x and sine is the y, and that's base and height. And 1 over root 2 and 1 over root 2 is actually cos 45 and sine 45. But 45 degrees is actually 180 divided by 4. And this makes sense because we know that it has to be 180 over the number of sides because the inner angle is 360. So we divide 360 by the number of sides and then divide by 2 since the angle is bisected. So that's technically the same thing we did. So the area of this figure is 4 cos 180 divided by 4 sine 180 divided by 4, which actually means the area of any figure with n sides is n times cos 180 over n times sine 180 over n. And as I said before, this ends up equaling 2. But what happens if we have 10? The area is then obviously 10 cos 180 over 10 sine 180 over 10, which is 2.39, and so on. And then if we use 10,000, it actually ends up equaling 3.14159244477. But that's not exactly pi, obviously. So why is this the case? And as you can see here, the triangles and shapes inside this figure, as the size increase, they slowly start to look more and more like a circle. This obviously doesn't look like a circle, and 5 starts to look like it more. And 19 actually is pretty hard to distinguish. And after a certain point, it's impossible for the human eye to distinguish without this equation. So as I said before, 10,000 is 3.141592444, and so on. And 100,000 is 3.141592653, and that's actually where it stops being correct. So we'll technically never reach the exact numbers of pi if we're always inside the circle creating more sides, because ultimately reaching pi is impossible because a circle has an infinite number of sides. But we can actually do this when a polygon is circumscribed around a circle too, not only inscribed. So I chose a pentagon here because it's a little more complicated than a triangle and a square, and I think it is a good example. So if we take this middle, we know it's 360 divided by 5, which is 72 degrees, which is the angle for this triangle. And if we take one of these smaller triangles out, we know that this angle is 72 divided by 2, which is 36. And the the height is 1 because the radius acts as an altitude to our triangle, and this is x. So we can use tangent here because the angle is a right angle, and a tan equals opposite over adjacent, so this is tan 36 equals x over 1. So x actually ends up equaling tan 36. And we know that the area of the total figure is 5 times this triangle. So it's actually 5 times 1/2 times 2 tan 36 times 1. And it's 2 tan 36 because obviously we got x, and we need to have 2x to get the full base. And these 2's end up canceling, so it ends up being 5 tan 36. 36 is also 180 divided by 5. So if we're trying to find the area of a 5-sided figure, we know it's 5 tan 180 over 5. So for the area of an n-sided figure, we know that the area of n equals n tan 180 over n. Just like before, when it's a 5-sided figure, it's 3.6 638. When it's 100 sides, it's 3.14262. And when it's 10,000 sides, it's 3.14159275559, which is obviously, that's where it stops being pi. And I just did this by plugging 5 and 100 and 10,000 into this equation. So circumscribed and inscribed are different because in one, the circle in the inside is smaller and getting bigger, and the other, it's bigger shape and getting smaller as it approximates the circle. Clearly, as the number of sides increase, it better approximates the circle. So that's how the equations are different. The patterns I saw, which actually was kind of interesting and it is pretty cool, if you can figure out what 1 through 10 is, you can actually figure out any other triangle, because technically if you know the area of a 3-sided polygon and you want it to get to 12, you just multiply that by 4, which I thought was kind of interesting if you didn't have these equations. The problem-solving strategies I used were generally just SOHCAHTOA and a little bit of common sense and just trial and error. It took a little bit to see the patterns and to find these equations, but them being right triangles and having the figures really helped a lot. I hope this is a good presentation.